Okay, everyone. Hello. This is my first devlog of Theta, which is a little game engine I've been working on. So, because this is like the first devlog, and I've been working on this game engine for over 2 weeks, there's gonna be a lot to show, but I think I can show it in this video. You see, I've got a lot of C files that I need to show. That's a lot of files. Okay, so the first thing I did with Theta was create some sort of build system, because that's pretty important on, a game engine. Basically, I have a simple CMake. It's set up weird. I don't have like a root CMake and then sub CMakes. I just have completely separate. They're considered like completely separate projects. So I have CMake lists for my game engine and CMake lists for my sandbox tester. These are completely different. They have no linkage, which kind of sucks because it means I have to make weird commands every time. But basically, I just set up a very simple build system, built CMake thing for Theta and simple one for sandbox. Although I don't have this glob get sources that I have in this because it's just main.c. I don't really need anything special for that. But also, I need to talk about the engine structure. I created a simple windowing system. Obviously, it has to be multi-platform support. So what I did was I created this uninterpreted data handle. That's just what I call every opaque handle in my game engine. I call it uninterpreted data. You need to specify the API that the window is going to initialize under. You need to specify the rendering context that it's going to have. And then I have these little function pointers. This is just because this is just so that you initialize it once and then you can just call these function pointers, and it's very simple because multi-platform makes it easier for multi-platform. So in my shared window, which shared window just means PC, so I'm using GLFW for this, but in my shared window I just in the initialize function, I do the profile and I just set these function pointers here. And I just do basic windowing stuff. If you're wondering what this macro is that I keep referencing, I have this core header file, and I have a simple logger, but I also have like little simple defines like true is 1, false is 0, bool. I have a simple assert macro. Init struct is really useful because you can say init struct and then give it the type, and it's gonna auto cast it, which is really, really useful. And data cast. Basically, this data cast thing, it just makes it so that you can cast the uninterpreted data very easily. You can see data cast, Theta shared window specifics, window, and window handle. You see, it uses uninterpreted data, so that's why it literally has to be named uninterpreted data for my macro to work, which is pretty cool. So that's the basic windowing system. I think it would be important to talk about the list. This isn't really like my strong suit in terms of what was good in this engine. I need to refactor this. But basically, it's just a simple dynamic list. It's like a vector in C++, but I obviously had to reprogram it because I'm using C. This pop front doesn't do anything. Don't worry about that. But yeah, it's just a simple, like a vector class. It's really simple. Obviously, you have to use void pointers because C doesn't have templates. Timer is really useful because you need to be able to get get intervals between time. So I have a reset and a lapse. Those are honestly the two only functions that I really needed to make. And obviously, I had to create Win32 version and POSIX version because the problem with C's simple timer is it only counts in like seconds, which is not good enough. It's nowhere near precise enough. So I have to use platform specific timers. So for Win32, I use query performance frequency and query performance counter, and I just do this weird math, and it does the job. For POSIX, since I develop on Arch Linux as my main and use Windows as secondary, I also did a simple POSIX implementation, clock a get time, and then I think POSIX is way better. I think it's a way better API, honestly. I think Win32 has some weird things that just they like over-engineer things in Win32 API. It's kind of annoying. Renderer. Actually, no. Yeah, let's talk about the application instead. The renderer is going to be like the last thing. I implemented a basic application structure. So you have like application in it. It requires you to give it a descriptor, application descriptor. This is just the name of the app, the start callback, the update callback, the terminate callback, and the API you want to initialize the app for, like OpenGL, Vulkan, blah, blah, blah. And so we have an init, run, and destruct. Very simple functions. I mean, the init just calls some basic stuff. You see, this init struct is very useful because instead of doing this, instead of doing that, you just do this, init struct, and it does everything for you, which is pretty cool. Well, I probably should move this there. It's it prefixes the app name by powered by Theta, which is kind of corny, but I thought it was cool. Default size is 1280 by 720. Probably should make user defined because this is hard coded. It's not good, so I'm gonna do that later. Input system. I do like my input system. I think I did a pretty decent input system so far. Basically, the input system just connects with the window. Basically, the way the input system works is you can have multiple inputs, and each of these inputs can have input descriptors, which can have separate input layouts. Basically just means I can have an input walk, for example, and walk can just have walk is the grouping of inputs, but you can have separate inputs for walk. You can say A and D keys to walk left and right, left joystick, move it left and right to walk, and other controllers and joysticks. So that's the beauty of this input system, is you can have multiple layouts. You can only have 10, so more than 10, that's it, because this is C. You kind of need to hard code some values a lot of the times because I don't want to deal with heap allocated stuff. C actually makes you not want to do heap allocation. So that's one of the beauties of C, is it like, because of how annoying it is to heap allocate things, you just tend to avoid it because it's annoying. So yeah. So that's just how my input system works. My renderer is not well designed. Let's talk about my math class actually. I have a simple math class, or not class, but library. It's just has matrix and vector. vector 3f, that's kind of the thing. There's only one type of vector. I really like how elegant the math library is, because there's no operator overloading because it's not C++, and there's no function overloading. So that's why I have mul and mul s scalar, div and div s scalar. I have more to implement. And matrix stuff, simple, have a little copy function. The vector object didn't need a copy function because it's just 3 floats. You don't need a function for this. But you do need a function for matrix because, well, actually, I don't know. Does this, if it's, correct me if I'm wrong, but if it's like this, does it treat it? No. Okay, no. I was going to say something dumb. This still needs to be manually copied because when you get the struct later in a different function, you're only going to have a pointer. So, yeah, no. You still need a copy function for that. Anyways, renderer. Renderer is simple. Actually, no, it's not. It's a little convoluted, but I have a renderer and I have a rendering context. So the renderer has a window, the context, and a list of packets, which is what rendering list is. Init initializes the renderer. Begin frame is what you should call before all rendering. Submit is what you do to submit to the rendering stack, and then end of frame finishes all the rendering and preps it for the next frame. Get context gets the context associated with the renderer. Get API gets what API it's initialized under, and destroy obviously destroys the renderer. And it's somewhat simple. I mean, you look here, initializes a list of renderables, specifically pointers, because pointers to renderables. And because I don't want to copy the memory into the list, because ultimately this isn't getting the ownership. The renderer does not get the ownership. It's the person that created, or it's the scene that has the ownership. The scene should have the ownership. So I have a begin frame that just calls clear on the context. I have submit. All this does is push to the rendering stack, and then end frame renders all of them and swaps the buffers on the context. And simple. It's pretty simple. I don't have anything here yet. I will though. Basically, if you look at my context, it has these function pointers, which is clear, swap, and destroy. And the only implementation I have so far is the OpenGL context, which has those functions defined here, and it initializes for OpenGL here. I have the way my renderable works is it has a mesh and a material attached to it. The mesh has basically just data and vertex position count. Those are the only useful stuff to, well, those are the only data. This is just kind of the function pointers associated with the mesh. And basically, obviously, these C files aren't really important to look at because it just switches the API and initializes based on the API you're in. So the OpenGL mesh is more interesting to look at because basically, you get the context, you set up the specific data, you create a VBO, text coordinate VBO, and that's about it for the vertex buffer and vertex array object. And then, create index buffer and then set up these little render and destroy. The render just calls VAO draw. The annoying thing with my render, with my graphics engine, is the VAO draw holds on to the shader, the index buffer, and all that stuff. And if you actually look at this definition, it's kind of convoluted because it even involves the textures too. Ideally, I should move this out of VAO draw. I will at some point, but it gets the job done so far. I'm kind of focusing on other parts of the engine. But, you know, my texture system, it's simple. No resource manager, as you can tell. You need to kind of make one, probably. Shader. Shader is interesting. So basically the way it works is you tell it what type of shader to use. You don't really give it a shader. I mean, you can, but you probably should just use the default shaders. But if you make your own shaders, it kind of has to conform to Theta. So you need to have these names in your shader. Like, you need to have specific names in your shader. If you don't, then it's not going to work with my engine, because the shader and the engine are very intertwined. I actually don't know how Unity does it, how Unity is able to maintain custom shader system and implement their like whole shader system. I don't really know. But overall, I have the main.c file for the sandbox, and if we build this, let's just double check that it builds. But oh shoot, we're lagging. Let's see. Fingers crossed this builds. I didn't commit a faulty project, at least I don't think I did. Okay, take your sweet time. I guess we're gonna talk about how the sandbox queries from the engine while we're waiting. So this is what the main function looks like. Creates a descriptor, puts the name sandbox as the app name. Wow, it's doing a lot. That's not even my library. Glad is not my library, and apparently it's got a lot of weird things. Okay, you're done now. You don't have to give me a bunch of warnings. This isn't my library. Chillax. Something tells me it's not gonna stop. Okay, there we go. There we go. It's done. It's finally done. Okay. Whew. Anyways, the way I query data it's pretty simple. So I have a data application pointer. When you initialize your app, you need to call data application init. This returns a heap allocated application. And you need to give the descriptor. Obviously, OpenGL, start, update, terminate. Those are the function callbacks. Run, and then immediately call destruct after it finishes running. Which, by the way, run calls a while loop. So, yeah. I'm actually going to not wait. Yeah, so this init's a quad colored. Let's actually check to see if if my cube system works, because I haven't tested that yet. Let's see if it can render a cube yet. Let's see if it should, but you know, my math may be wrong, so we'll see. Oh, great, we got a cube. Sick. That's cool. There are obviously other things you can do, like let's render a different object. Let's say game object equals theta game object init. We give it the transform and the renderable. So we're going to say renderable init quad. We'll give it a file path. We're going to say steve.png. And then we're going to remove this rotation thing because we don't need it. Build. Generating build files. Wow, my computer's working hard right now. So this will also show my simple input system, but you can wait, hold on. Whoopsies. Forgot to uncomment this. But basically the way my input system works, you give it the input layout, you set the type to, you know, keyboard, and then you give the input layout a positive and a negative. So D is positive, A is negative, and then you bind that input. So sandbox input, walk, layout, on walk, and then my on walk function is right here. Very simple. It just gets the game object. It doesn't actually need the, oh no, it does. Yeah, so it gets the game object. It sets player movement to the axis times walking speed. This axis system is really similar to how Unity does it. I'm actually inspired by Unity. And if axis is greater than 0, make sure the rotation is flipped. Whereas if it's not, make sure it's this. So that just lets the thing flip around. So if you take a look, it looks like this. Pretty neat, huh? It's a little laggy because my computer is absolute dog crap and everything is lagging on it. Even Visual Studio Code was lagging. But basically, you know, very simple input system. It feels nice too. Feels really good. It was surprisingly difficult to get this working because how many systems I have. Look at this. This is how many systems get initialized and destroyed. In fact, only 3 things get destroyed, so that's a problem. I'm going to need to do more memory management. I wasn't really focused on that recently. But yeah, last thing is, you know, my scene integration. It's pretty cool. You know, you just create your objects, your camera. You have to create your own scene. You have to create your own game object. You can add a game object to the scene. When you initialize the scene, you must give it a camera also. You set the active scene to the scene manager. And, you know, you do your input stuff. And my update function looks like this, and my terminate function has nothing in it because I don't need anything in there. Overall, it's a pretty good game engine so far. I mean, you know, it's obviously got some downfalls, like how much heap allocation I'm doing. I mean, I haven't found a better way of doing this because the problem is heap allocation is kind of needed in a lot of places. Like scene in it, the scene must have ownership of this stuff, but what if the user wants ownership too? And I want the memory to last long. I want I don't want it to go past this scope. So I thought the best way to do that was some heap allocation. But obviously this transform does not need to be heap allocated. And even when you go into the object, when you go into the object, you can tell, what? Hello? IntelliSense? Can you work? Okay. I guess IntelliSense doesn't want to work right now. Okay, it wants to work for that. But I was trying to show, yeah, the transform is not heap allocated. Neither even is components. You can only have 30 components on your game object. I don't think you need more than that. I mean, when are you putting a cajillion rigid bodies? You only need one rigid body, one renderer, like a few scripts maybe, and that's like 10 maximum. So I'm being generous, allowing you to have 30 on this game object. I don't think that's going to be an issue. Again, I'm trying to avoid those heap allocations because they're so annoying to query for. And yeah, so I don't have an event system. That's kind of sad. But I have a somewhat cool input system. Right now, you can't bind multiple inputs, so that whole thing about being able to like bind controller and other stuff, that it doesn't work yet, but it's really simple. All I need to do is make bind input allow for multiple on the same one. It's really easy. It's just like a few more lines of code. So I'll do that. And yeah, this is Theta. This is how Theta is so far. It's one of my personal projects that I want to work on, that I really enjoy, and I'll continue to vlog about it. This is the first devlog for Theta. Hope you enjoyed. Bye.